Hey everyone, welcome back to NIIT YouTube channel. And my name is Mukul, and this is episode 3 of our LangChain by Project series, where we don't just learn about AI, we build real end-to-end application using LangChain technology. And today, we're building something really practical and honestly super important in the Gen AI world. We're creating a RAG app. Basically, it lets you chat with any PDF you've got lying around, and we're building it using LangChain, Llama 3, Streamlit, and Chroma, and finally running everything locally with Ollama. I will give you a proper step-by-step walkthrough from code and how to build this project. And by the end of this video, you'll know how to go from here's a random PDF on my laptop to I can ask questions and get grounded answers from it. Alright, before we start building the project, let's understand what RAG really is. Alright, let's start with a simple question. Why do we even need RAG? Think of a normal large language model like GPT or Llama as a really smart autocomplete. It's trained on a huge amount of data, but it still has some limitations. First, it doesn't know your PDFs, your reports, your policies. Second, it has a limited context window. You can't paste a 300-page document into it every time. And third, if it doesn't know something, it may hallucinate, meaning it confidently makes things up. And to solve this problem, we use RAG. You might be wondering, what exactly is RAG? RAG stands for Retrieval Augmented Generation, and it's the method that fixes all of these issues by connecting your own data with the model. Step 1. The high-level RAG flow. Now, let me break this down visually. On one side, you have your PDF. It could be a report, a white paper, a policy document, anything. On the other side, you have the LLM. In our case, Llama 3. RAG acts like a bridge between the two. The entire pipeline looks like this: PDF, chunks, embeddings, vector store, retriever, context, LLM, answer. Let's go through each piece one by one. Chunks. We start by extracting text from the PDF. Then we split that text into smaller manageable pieces called chunks. Why do we do this? Because the LLM can't handle the entire PDF at once, and embeddings work much better when each piece of text is shorter and focused. So we break the document into roughly 800 character chunks with a bit of overlap so we don't lose important context between sections. Embeddings. Next, each chunk is converted into an embedding. An embedding is basically a long list of numbers, a vector, that represents the meaning of the text. Two chunks that mean similar things will have similar vectors. You can imagine it like dropping text into a high-dimensional space where similar ideas naturally appear closer together. Vector store. Now we take all those vectors and store them in a vector database. In this project, we're using Chroma. Chroma stores the embedding, the original text, and metadata like the page number. This allows us to instantly ask, given this question, which parts of the document carry the closest meaning. Retriever. On top of the vector store, we use a retriever. So when a user asks something like, what is the main conclusion of this report? Here's what happens. We convert the question into an embedding. We compare it against all the chunk embeddings in the vector store, and we pull out the top matching chunks. These are the pieces most likely to contain the correct answer, or at least the right context. Now that we understand how RAG works conceptually, let's switch over to VS Code and walk through the actual project file. I want you to see how everything we discussed translates into real code. Alright, so let's start right from the top of our script where we bring in all our imports. We begin by importing Python's temporary file module and Streamlit. These two help us handle uploaded files and build the UI for the app. Then we bring in all the tools we need from LangChain. We import chat Ollama, which lets us talk to our local Llama 3 model. We also bring in the PDF loader to extract text from the document page by page, and the recursive text splitter, which helps us break long text into smaller overlapping chunks. After that, we bring in Ollama embeddings to convert each chunk into a numerical vector the model can search. And finally, Chroma, which becomes our vector database for storing all the embeddings and the original text together. We also import the chat prompt template to structure the RAG prompt and runnable pass-through to wire everything together using LCEL. Right after the imports, we set our model name to Llama 3.1, which simply tells the app which local Llama model to use through Ollama. Then we define two helper functions. The first one is getLLM. This returns a local Llama model with a low temperature so the answers stay focused and clean. The second one is getEmbeddings. This returns the embedding model that turns each chunk of text into a vector. Both of these functions are cached, so Streamlit doesn't reload the model every time the UI refreshes. After that, we get into the part where we set up the RAG indexing. We create a function that takes the uploaded PDF and turns it into a vector store. Inside this function, we first check whether the user actually uploaded a file. If not, we stop and show an error. If a file exists, we save it temporarily so the PDF loader can read it from a proper file path. We load the PDF from that path and extract text from each page. If nothing can be extracted, we let the user know. Once the text is ready, we create our text splitter and break the document into chunks of around 800 characters with some overlap. These chunks are then embedded using the embedding model. And finally, we store everything inside a Chroma vector database. So this entire function basically takes a PDF, extracts the text, chunks it, embeds it, and turns it into a searchable vector database. Next, we build a RAG pipeline. We create a function called makeRagChain, where we pass in the vector store, the number of chunks to retrieve, and the preferred answer style. Inside this function, we convert the vector store into a retriever. Its job is simple. Look at the user's question and pull the top k most relevant chunks. Then we define a helper called joinContext, where we take the user's question, use the retriever to fetch the relevant chunks, and then join their text together into one combined block of context. If nothing relevant is found, we return a friendly fallback message. After that, we define our RAG prompt using the chat prompt template. The prompt tells the model to answer only using the PDF, to clearly say when something isn't present, and to follow the user's preferred answer style. Then we build our LCEL chain, where we take the question, fetch the context, combine everything inside the prompt, and then send the final prompt to Llama 3 to generate an answer. We return both the chain and the retriever so we can also fetch the exact source chunks later. Then we move into the Streamlit part of the app. We initialize the session state and make sure we have a place to store the vector database and the chat history. The chat history holds each question, the model's answer, and the PDF excerpts used for that answer. Now we move into the main interface, where we set the page configuration, display the title, chat with your PDF, and add a short caption explaining what the app does. Inside the sidebar, we create the settings panel. Here the user can choose how many chunks to retrieve, pick whether they want short answers or detailed answers, and they can click a reset button to clear everything and start fresh. Then we build the main layout with two columns. On the left side, we handle PDF, upload, and processing. The user uploads a file, clicks Process PDF, and we extract the text, chunk it, embed it, and build the vector store. If everything goes well, we show a success message and a few example questions they can try. On the right side, we create the chat interface where the user can type a question and click Ask. When that happens, we build the RAG chain using the current vector store, run it to generate the answer, and fetch the source chunks used for that answer. We save all of this into the chat history, which stores the question, the answer, and the relevant parts of the PDF. Each answer appears clearly on the screen, and the user can expand a View Sources section to see exactly which parts of the document were used. This adds transparency and helps avoid any hallucinations. And finally, at the bottom of the file, we have the standard Python main check. This simply means if the script is run directly, it launches the Streamlit app. Once everything is installed and running, you can upload any PDF, process it, and start chatting with it right away. Now that the code is ready, let's jump into VS Code and actually run this project. I open the terminal inside VS Code, where we start by installing all the required libraries. So we use pip to install Streamlit, LangChain, the LangChain community extensions. Once everything finishes installing, we're ready to run the app. In the terminal, we type streamlit run eprag pdf streamlit.py and press enter. Once the app opens, we land on the main page where we see the title and a short caption explaining exactly what the app does. On the left side, we have the space to upload our PDF, so we pick a PDF from our system and upload it. After uploading, we click the Process PDF button, where the app reads the file, chunks it, embeds it, and builds the vector store in the background. When everything is done, the app shows a success message and gives us a few example questions. Now on the right side, we have the chat interface where we can start asking questions about this PDF. So we type a question, something simple like, what is the main conclusion of this document? And click the Ask button. The app runs the RAG chain behind the scenes, and after a moment, we get our... This makes the whole experience transparent, because we can verify every part of the response against the original document. You can keep asking more questions, try different parts of the PDF, or experiment with detailed answers versus short answers. Everything is running fully local, powered by Llama 3 through Ollama, and all the context retrieval is handled by Chroma and LangChain's LCEL pipeline. And with that, the entire app is up and running, and you've now built a working RAG system end to end. So that's our complete RAG app, where we take a PDF, turn it into chunks, embed those chunks, store them in Chroma, use a retriever to pull the right context, and then wire everything together through LangChain's LCEL to talk to a local Llama 3 model. This is the exact pattern behind so many real-world Gen AI tools: internal document assistants, research copilots, knowledge bots, and more. And now you understand the whole flow. In the upcoming episodes, we're going to build even more amazing projects using LangChain, step by step, hands-on, and fully practical. So if you found this useful, hit like, drop your questions in the comments, and subscribe so you don't miss the next videos in this LangChain by Project series.